Hello everyone, welcome to OHM online classes. Myself Giri, faculty of OHM Institute for Power System subject. In this series, we will discuss detailed solution for all gate PYQs related to power system subject in topic wise. So in this video, we will discuss basics of power systems and line parameter calculation topic questions. Let's start with 1 mark questions first, later we will move on to 2 mark questions. Let's see the first question. So in this question is clearly mentioned, when a fixed amount of power is to be transmitted, the efficiency of transmission increases when, and all the options saying about voltage and power factor. Now we will try to understand first what is the relation between efficiency with voltage and power factor. Now truly speaking, the efficiency increases if losses in the transmission line decreases. So that's why we'll try to understand the relation between losses with power factor and operating voltage of the system. For example, if you see the equivalent circuit of transmission line, I'm drawing here the approximate equivalent circuit of transmission line. XL is the reactance of the line. Okay. Now the voltage of the system is V, the power transferred is P, then the current through the line is I. Now to calculate the power loss in the resistors, don't take V square by R, because that V is the sending end voltage. It's not the voltage across the resistance. If I know the voltage across the resistance, you are right, V square by R is correct. But here for transmission line, better to write the power loss is I square R, because resistance is a series element, it's not a shunt element. So what is the power loss here? Since it is a 3-phase line, I can write 3 times the magnitude of I square into R. But what is the relation between power and magnitude of I? We can write like this, root 3 into, I am assuming this V is the line voltage and the line current, okay, into cos theta s, where cos theta s is the sending end power factor, theta s is the sending end power factor angle. Now simply this is what we call power factor, okay. Now what is the expression for I? P by root 3 into V into power factor cos theta s. Now let's substitute in power loss. What I get? The power loss equal to, so I square means in the denominator 3, in the numerator here 3, both get cancelled. Directly I am writing, don't confuse. So we can write P square by what? Magnitude of V square into cos square theta s, and whole thing multiplied with what? Resistance R. So from this we can understand the power loss is what? Inversely proportional to the voltage square and what? Power factor square. Now what you can understand from this? If voltage increases and power factor increases, both voltage and power factor increases, power loss decreases. Power loss decreases means what? Efficiency increases. Now in this question is clearly saying efficiency of transmission increases when voltage increase and what? Power factor increase. So the option for this question is B. So if both voltage and power factor increases, no, definitely losses in the transmission line decreases and efficiency of transmission will increase. Now we will move on to the next question. See this question. The inductance of a power transmission line increases with option A, decrease in length, option B, increase in diameter of the conductor, option C, increase in spacing between the phase conductors, option D, increase in load current carried by the conductor. See, truly speaking, the inductance depends on 3 factors: length of the line, spacing between the conductors, and also size of the conductor. It's not depends on load current carried by the conductor. So I can eliminate directly this answer. Okay. But let's see what is the inductance formula. The formula for inductance is 2 into 10 power minus 7 ln GMD by GMR. GMD by GMR. Now if you see in this formula is written per meter length. Means if the length of the line increases, the inductance will definitely increase. Now this is the formula valid for 1 meter length. If it is 2 meter length, this formula must be multiplied with 2. Suppose if the length of the line is 3 meters, this formula multiplied with what? 3. So that's why inductance is directly proportional to, from here I can write the inductance is directly proportional to length of the transmission line. Length of transmission line. And directly proportional to ln of GMD by GMR. GMD means what? Geometric mean distance. GMR means geometric mean radius. GMD depends on spacing between the conductors. GMD is directly proportional to spacing between the conductors. Spacing between the conductors. But what about GMR? That is directly proportional to size of the conductor or diameter of the conductor or radius of conductor. All are correct. So from this we can understand clearly, if GMD increases, ln function increases, inductance will increase. GMR increases, ln function decreases, inductance will decrease. But he has mentioned clearly, the inductance of transmission line increases with what? Increase in GMD or decrease in GMR or increase in length of the line. But if you see option A, decrease in length, actually if there is a decrease in length, inductance will decrease but not increase. Increase in diameter of the conductor, increase in diameter of the conductor means GMR will increase, ln function will decrease, inductance will decrease but not increase. So this is also not correct. Yes, increase in spacing between the conductors. Yes, if there is an increase in spacing between the conductors means GMD increases, so inductance also increases. So that's why the best option for this question is C. Now we'll move on to the next question. So in this question, he has mentioned a three-phase overhead transmission line as its conductors horizontally placed with spacing between the adjacent conductors equal to D. If now the conductors of the line are rearranged to form an equilateral triangle of side equal to D. That means initially conductors are what? Having horizontal configuration. Later equilateral spacing. Now from horizontal to equilateral spacing, what happens? Conductors are same, means what? Their size is same, their radius is same, GMR will same. But what happened to the GMD? If you know that, you can get the answer for this question very easily. Let's see. If the conductors are having horizontal spacing, then if they are horizontal spacing and adjacent conductor distance is what? D, right? The adjacent conductor distance is D. If that is the case, this distance is what now? 2D. So let's say this is A, B, C. So indirectly here X is the distance from A to B, Y is the distance from B to C, and Z is the distance from A to C. X equal to Y equal to D, but Z equal to what now? 2D here. So if you write the GMD equivalent or simply GMD, that is cube root of XYZ. This is generalized formula for three-phase transmission line. Okay. Now this will give you, directly I am writing 2 power 1 by 3 D. 2 power 1 by 3 value is greater than 1. You know this. Now the conductors are arranged to form an equilateral triangle of side equal to what now? D. For this particular case, what is the GMD? That is simply D. Tell me in which case the GMD is more? GMD is more for first case, not second case. That means when you move from first case to second case, GMD decreasing. If GMD decreases, what happened? Inductance will decrease, because inductance is directly proportional to what? Ln of GMD by GMR. But capacitance is directly proportional to 1 by ln of GMD by GMR. So tell me what happens now? If GMD decreases means ln function decreases. Ln function decreases, inductance will decrease. Ln function decreases, capacitance will increase. So average capacitance will increase and average inductance will decrease. Okay. So that is the best answer here. So what is the best answer? Average capacitance will increase and inductance will decrease if you move from horizontal configuration to symmetrical configuration. So the best option is C. Now we will move on to the next question. See, in this question, the increase in resistance due to non-uniform distribution of current in a conductor is known as. So it is known as skin effect, correct or not? Due to skin effect, there is a non-uniform distribution in the conductor that results in what? Increased resistance of the conductor. We know already these things. So the answer for this question is skin effect. Okay. Now we will move on to the next question. See, in this question it is mentioned the insulation level of a 400 kV EHV overhead transmission line is decided on the basis of. It's clearly mentioned insulation level of what? 400 kV EHV overhead transmission line. So generally insulation level of a overhead transmission line having insulators, right? Okay. Those insulators are designed for peak value of system phase voltage for a continuous operation. But for transient operation, the same insulators are designed to withstand both lightning over voltage and switching over voltage. So lightning over voltage and switching over voltage is the criteria for selection of what? Insulation of overhead transmission line. But which is maximum? That is the real deciding criteria. Suppose if lightning over voltage is maximum, so we decide insulation based on lightning over voltage. If switching over voltage is maximum, then we decide insulation based on switching over voltage. But tell me which is maximum here. But we can answer like this. If operating voltage is less than 300 kV, no? Then lightning over voltage is greater than switching over voltage. Similarly, if operating voltage greater than 300 kV, then it's reverse. Switching over voltage is greater than what? Lightning over voltage. That's why less than 300 kV criteria is what? Lightning over voltage. Greater than 300 kV, switching over voltage. So in the question is asking about 400 kV, that fall under what? The second category. So that's why the answer is what? Switching over voltage. So for a 400 kV transmission line, the insulation is decided based on switching over voltage. Now we'll move on to the next question. This question is related to topic called corona. So it's clearly mentioned corona losses are minimized when, or corona losses are decreases when. Generally corona losses depends on what? Size of the conductor and smoothness of the conductor, and even current density also indirectly affecting the corona loss. But if you really notice, if size of the conductor increases, the gradient at the surface of the conductor will decrease, which results in less ionization of air, which results in reduced corona losses. So indirectly, if gradient increases at the surface of the conductor, definitely corona loss will increase. But gradient or electric field intensity or electrostatic stress at the surface of the conductor is directly proportional to operating voltage and inversely proportional to size of the conductor. Now tell me, if the size of the conductor increases, what happened? Gradient will decrease, reduced corona. If size of the conductor reduces, gradient will increase, then increased ionization, increased corona and increased corona loss. So by seeing this, we can say the first option is not a correct one. Why? Because conductor size reduces, what happens? Gradient will increase, corona will increase. Smoothness of conductor is reduced, not size, smoothness of conductor is reduced. See, if the conductor is, if the conductor surface is what? Lot of irregularities. That means if the conductor is not a smooth conductor, then at the edge points the electric field intensity is high, so that more chances of corona and more chances of corona loss. So that's why, so smoothness of conductor is reduces means corona loss is more. So that's why this is also not a correct option. Sharp points, just now we discussed, if sharp points of the line hardware is increasing or sharp points are provided on the line hardware, then more corona loss but not less corona. Now the last option is definitely correct one. But how can you understand this? The current density of the conductor is reduced. What is the meaning of current density? J equal to I by A, where A is what? Cross section area of the conductor, that is pi r square. The current density reducing means what? Indirectly cross section area of the conductor is increased. Means what? The radius of the conductor also increased, or size of the conductor also increased. If size increases, just now we discussed, the gradient at the surface of the conductor decreases, which results in reduced corona. Okay, clear? So the option is D. Now we'll move on to the next question. So in this question, he has clearly mentioned there is a two-wire conductor. Radius of the conductor is given, spacing between the conductors is given. But what is asking? If the distance between the conductors is doubled, then the inductance per unit length is distance between the conductors, means what? GMD is doubled indirectly. So what is the formula for inductance for a two conductor system? 2 into 10 power minus 7 ln d by r dash. So let's say we have two conductors here. The spacing between them is what? I am assuming d. Now this d become doubled. If this d doubled, what happened? Ln function will increase but not doubled. So inductance will increase but not doubled, because here inductance is not directly proportional to d here. Inductance is directly proportional to ln of d, not just d. That's why don't be in trap here. So it's not doubles, but many people will think that it is doubled. Okay, mathematically ln function, if the ln of something is doubled means ln function will increase but not double. So that's why the best answer is increases but not doubled. So answer is C. Now we'll move on to the next question. Let's say in this question, bundle conductors are mainly used in high voltage overhead transmission line to reduce the transmission line losses, increase the mechanical strength of the line, reduce corona, reduce sag. What is the best answer? Obviously to reduce the corona. If you really notice, in our Indian power system, 220 kV onwards we use bundle conductors. The main reason is corona is generally occurs for 220 kV and above operating voltage. That's why for 220 kV and above operating voltage we use the bundle conductors, because if you use the bundle conductors, GMR will increase, gradient at the surface of the conductor will decrease, so that there is a reduced corona. In fact, the line design or size of the conductor for 220 kV and above operating voltage is selected by reducing corona. Okay, so by keeping the corona as low as possible, we select the size of the conductor for 220 kV and above operating voltage. Or in fact, the line design for 220 kV and above operating voltage is always based on corona only. Okay, coming to the bundle conductors. Yes, if I am using bundle conductors means the main reason is to reduce the corona. But apart from reduction in corona, there are so many other advantages of bundle conductors. Because of bundle conductor, just now we discussed, GMR increases. GMR increases means inductance will decrease, capacitance will increase, surge impedance root over L by C, that will decrease, surge impedance loading will increase. All these are advantages. Even if inductance decreases, reactance of transmission line decreases. So reduced reactive power consumption in the line, since reactance decreasing, and impedance of the line decreases. That means reduced voltage drop in the line. Since reactance decreases, Pmax, maximum power transfer capacity of the line, or steady state stability of the limit of the line will increase. So all these are the advantages of bundle conductors. But if you ask me what is the main reason for going of bundle conductors, the answer is to reduce the corona. So the option is here, to reduce corona. Clear? Now we will move on to the next question. See this question. The rated voltage of a three-phase power system is given as, always in a power system the rated voltage is line voltage. But the question will come whether it is RMS or instantaneous or peak. Always it is a RMS line to line voltage, otherwise simply line voltage, but not phase voltage. If it is specified, phase voltage means you can consider, but by default it is always line voltage. For example, a question is given like this: 11 kV 3 phase 50 Hz 5 MVA transmission line. Now tell me what that 11 kV indicates. He has not mentioned whether it is RMS or peak value or instantaneous, but by default it is RMS voltage. But tell me what that 11 kV indicates, whether it is a line voltage or phase voltage. Yes, it is always line voltage. It's not mentioned whether it is line voltage or phase voltage, but by default it is what? Line voltage only. That means the rated voltage of the power system is always line to line voltage, that to RMS voltage. So the answer for this question is RMS line to line voltage. It's a fundamental question. Now we'll move on to the next question. If you notice this question is already asked, correct or not? Just now we discussed. The insulation strength of an EHV transmission line is mainly governed by, but he has not mentioned the operating voltage here. But if you go through the options, so only one option is saying switching over voltage. Lightning over voltage is not there. That's why the answer is what? Switching over voltage. Truly speaking, the insulation level is decided either based on lightning over voltage or switching over voltage. But no other options is there except switching over voltage. That's why the best answer is B. Clear? Now we'll move on to the next question. This question is based on concept of interconnection. Whenever you are interconnecting the two buses or two networks or two systems, there are few things must be taken care. Number one, frequency must be same. Number two, voltage magnitude must be same. Number three, the phase angle must be same. Number four, the phase sequence must be same. Okay, these are the preliminary requirements. So this question is based on the phase angle. Clear? Now he is asking about what is the connection for this unknown transformer. But how to find out? To find out the unknown transformer connection, let's calculate the phase shift which is coming at this point and this point. So to answer this, you start with the generator. Assume generator phase shift is always 0 degrees. Okay. Now if that is the case, let's see, if you move in this direction, what is the phase shift here? 30 degrees now. That is provided by the transformer. So that means at this bus bar the phase shift is 30 degrees. Now if you move here, then in between we have a transformer between these two buses, right? So what is the phase shift? 0 degrees. Means what? 30 plus 0, again what here? 30 degrees. Correct? Now go like this. But in the direction he has mentioned like this. But in this direction, in the direction given, minus 30 is the phase shift here. But in this direction, this is what? Plus 30 degrees is the phase shift. Now 0 plus 30, again what here? Plus 30 degrees. Now tell me, what is the phase shift here? Plus 30 plus 30. That means this transformer should provide a phase shift of 0 degrees. So the option is what? Only A. Star star and theta should be 0 degrees. Again I am saying this question is based on the phase shift. To answer this question, you have to come to the unknown transformer from both the sides, from the upside and downside, starting from generators. Assume generator phase shift is 0 degrees, always, better. So proceed to what? Unknown transformer, one end and other end. Now by seeing the values here, you can understand. For example, maybe I got here 30, I got here 60. Then in that case what now? Phase shift provided by this is what? 30 degrees. Correct or not? Plus 30 degrees. The downside. And upside what? Minus 30 degrees. Okay? Clear? Understand? So that's how you need to answer the question. Clear? But anyway, we came to unknown transformer from both the sides. And we proved that here 30 degrees and here 30 degrees. And there is no phase shift. So that means the answer is A. Clear? So we'll move on to the next question. See this question. For a fixed value of complex power flow in a transmission line having a sending end voltage V, the real power loss will be proportional to. Again, this question also many people will confuse, because we generally study the resistance losses as V square by R or I square into R. But always we'll say that okay, V square by R, so directly proportional to V square. But that's not correct here, because when you are writing the formula for resistance losses as V square by R, that V must be voltage across the resistance. But what is the V given here? Sending end voltage. Correct or not? So in a transmission line, so this is the equivalent circuit of transmission line now. Sending end voltage is V. So we don't know what is the voltage across the resistance. That's why see the current through the resistance now. That is better. Tell me what is the power loss now? 3 into magnitude of I square into R. But how to relate with what? V here? Very simple. So we know that the complex power S magnitude root 3 V into I, where V is the line voltage, I is the line current. Now what is I now? S by root 3 into V. Now tell me what is the power loss expression? Directly I am writing magnitude of S square by magnitude of line voltage square into resistance R. Clear? If I substitute here the current, I will get this expression. So inversely proportional to magnitude of the voltage square. So the answer is C. Not directly proportional, inversely proportional. Otherwise directly proportional to 1 by V square. Otherwise directly proportional to V power minus 2. In that way also options are given. Clear? So careful. So that's it. We'll move to the next question. Let's go through this question. A single phase load is supplied by a single phase voltage source. A single phase load supplied by a single phase voltage source. Let's say assume this is the voltage source supplied by a, this is a voltage source feeding the single phase load, fine. But the current flowing from load to source is given. That means in this direction current is given. What is that? 10 at an angle minus 150. But this is opposite to the convention. What is convention? Load should always take the current from source. We have to see load, that is always take the current from source. Otherwise source will supply the current, load will draw the current. That is better. That means we want the current in this direction. In this direction. So this is the current we want. Tell me what is this current? Just minus it, enough. But how to write this current I? minus 10 at an angle minus 150 means what? This minus you can replace with, in polar form, either 1 at an angle 180 or 1 at an angle minus 180. Both are valid. It's up to you. But I will write plus 180 so that I will get a smaller angle. Resultant angle is very smaller. 10 at an angle minus 150 multiplied with 1 at an angle 180. So magnitudes will multiplied, phase angles will be added. So we get what? 30 degrees. Now what is the expression for complex power? P plus JQ. P plus JQ, that is equal to VI conjugate for single phase system. But if I calculate this, if you got both P and Q are positive, then load consumes the active and reactive power. Suppose if you got P negative, load supplies the active power. Q negative, load supplies the reactive power. So that's how we can answer. Since as per the load convention, if we calculate the complex power using usual notations, what is the usual notations? Source should supply the current, load should draw the current. That is a usual notation. If we use usual notation and calculate the complex power, then by seeing the sign of active power and reactive power, we can conclude about whether the element will consume the power or what? Supply the power. Consuming means absorb the power. Nothing wrong. Okay. But tell me, what is this? If you substitute, voltage is how much? 100 at an angle 60. Let me substitute that. Current conjugate, na? So conjugate. So 10 at an angle plus 30 means now I will get minus 30. So I get here 1000 at an angle plus 30 degrees. So I can write here 1000 cos 30 plus J times 1000 sin 30. So cos 30 will be root 3 by 2, 0.866. So what I can write now? 866 plus J 500. Both are what? Positive numbers. Both are positive numbers. That means what? The load consumes both active power and reactive power. So let's see what is the answer. Load absorbs the real and reactive power. So the option is D. So the load absorbs both real and reactive power. Clear? Now we'll move on to the next question. Again, it's a very simple question. For the configuration shown is asking to calculate what is the GMR. If you really notice, he has given 4 conductor system. The radius of all the conductors is known, that is R. So if that is the case, what is the distance from 1 to 2? This is R and this is R. So we get 2R. Here also this is 2R. But what about this distance, which is unknown? But we can calculate. This is 2R and this is also 2R. Now we can calculate D13. D13 means distance from conductor 1 center to conductor 3 center under root of using triangle rule. What I get? 2R square plus 2R square. Tell me what I get now? 2 root 2R. Clear? Okay, fine. But what is the formula for GMR? GMR means, since these are the 4 conductors, right? So I can write like this. D11, D12, D13, D14. I am writing with respect to conductor 1 first. But whatever the 4 terms we get with respect to conductor 1, same 4 terms we get with respect to conductor 2. That means same values we get. Conductor 3 also, conductor 4 also, because there exists a symmetry between what? These 4 conductors. Okay? Because they are forming what now? A square. If you join their centers, it forms a square. So definitely there exists a symmetry. That is the reason I directly writing only with respect to conductor 1 4 terms. For example, if you have a confusion about determining the symmetry, then don't worry. Write 16 terms now. What are the 16 terms? With respect to conductor 1, 4 terms we got. Similarly, with respect to conductor 2, how to write? D21, D22, D23, D24, 4 terms. With respect to conductor 3, D31, D32, D33, D34. With respect to conductor 4, D41, D42, D43, D44. Total 16 terms. Then it should be 16th root. But now, with respect to conductor 1 only I written. Why? Because all these 4 set of 4 terms are what? Same. That's why I can say this is 4th root. Okay? Clear? But you can cross verify. Writing with respect to conductor 2, conductor 3 and conductor 4. Total 16 terms and 16th root. Okay? Clear? Now, 4th root of D11 means R dash. What about D12? 2R. 1 to 2 distance, D13 2 root 2 R, D14 again 2 R. So what is R dash, by the way? 0.7788 R. You know this. Now if you solve this, I get 1.723 R. You can verify. We get 1.723 R. But this is the method, simple method. Okay, clear? So if you are any confusion, if you are unable to determine the symmetry, means 16th root of, how to write the terms? D11, D12, D13, D14. Similarly, multiplied with D21, D22, D23, D24. Then D31, D32, D33, D34. Again D41, D42, D43 and D44. Total 16 terms, 16th root. Again you solve like this, 100% you will get the same answer, because these 4 terms, whatever the value, 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 they are all same. Okay, clear? So finally the answer is what? 1.723 R. So option D. So that's it for 1 mark questions from basics and line parameter calculation chapter. So in the next video, we'll continue our discussion with 2 mark questions. Thank you and all the best.